Hi everyone, welcome to our third presentation in the Home on the Range webinar series. My name is Haley Mankey and I'll be hosting this session today. I'm a director for the BC chapter of the Pacific Northwest section of the Society for Range Management. We're really excited to offer this webinar series for our members to share the work that we're doing during these times. If you're enjoying the webinar series, I encourage you to check out our parent society, Society for Range Management's annual meeting and conference that will be happening in February this year. You can do so at rangelands.org. So today's presentation is titled Wildfire Risk Reduction Pilot Project, presented by Amanda Miller of Palouse Rangeland Consulting. So Amanda is passionate about rangeland stewardship and conservation, and she has a keen interest in providing ecological tools and strategies for long-term sustainable land management. Applied science, extension, and effective communication with stakeholders and land managers are key areas of interest. Amanda has a master's degree in rangeland and wildlife resources from the University of Alberta and has been a professional agrologist since 2016. As a rangeland specialist for the Government of Alberta from 2013 to 2019, she has worked to develop ecological tools, applied research, and policy to address emerging rangeland issues. The owner and founder of the Palouse Rangeland Consulting, Amanda works largely with the BC Cattlemen's Association and is a supporter of sustainable beef and cattle as a conservation tool. In her free time, you can find her exploring the mountains by foot, on skis, or horseback. So without further ado, Amanda, I invite you to share your screen and begin your presentation. Thank you.
All right, is that working, Haley?
Yes, I can see your presentation and hear and see you, so you're good to go.
Okay, wonderful. Well, thanks for the introduction, Haley. Before I delve right into this presentation, I wanted to acknowledge some of the major players in this project. So the BC Cattlemen's is spearheading this, along with support from the Ministry of Agriculture and Flynn Road. And myself, I'm part of a research team. The other part of it is Reg Newman, who I'm sure most people are aware of. And I've had the opportunity to work with in the field over this past field season. So a little bit of project history. So in 2017-18, there were some substantial fire seasons, and I'm sure everyone remembers them. I keenly remember it because in 2017, my uncle was, he was evacuated for flood in June, and then my father was evacuated for fire in July. And then everyone was joking that the other brother would have some sort of plague or pestilence befall him. And that was funny at the time, not so funny in the era of COVID. But anyway, I keenly remember 2017 fire season, and 2018 was particularly bad as well. So during these fire seasons, it became apparent that there was a lot of value in agricultural practices on the landscape in helping to influence and change fire behavior. These areas that were grazed in specific helped to act as agricultural fire breaks. They were slowing, turning, and stopping fires across the landscape. So with this in mind, following the 2017 and 18 fire seasons, the BC Cattlemen's Association worked on partnering with the province and interested ranchers to develop a pilot program to explore the use of targeted grazing to create these agricultural fire breaks. Within this project, targeted cattle grazing would be used to reduce or break up fine fuel loads and address wildfire risk next to communities, utilities, and transportation corridors. And this is a really valuable thing to do because, for example, in 2017, 1.2 million hectares was burnt, 65,000 people were evacuated, and it was almost $650 million in fire suppression costs that the province had to deal with. In 2018, similarly, there was 1.3 million hectares burnt. Less people evacuated, but it was still problematic with about 2,200 people. And again, over $600 million in fire suppression costs. So it's important to have another tool in our toolbox to help address these wildfire risks, as we're probably going to continue having wildfires. So a little bit of discussion on what targeted grazing is and why we're using it as a fire suppression tool. So targeted grazing at its core is defined as the use of a specified kind of livestock for a determined season, duration, and intensity to accomplish defined vegetation and landscape goals. That's targeted grazing in a nutshell. So why is it important within the context of fire suppression in the urban interface? Well, most fuel management projects, specifically in British Columbia, they tend to focus on tree canopy characteristics. This is because high intensity fires are carried throughout forested areas. So many fuel management projects focus on the removal of trees, decreasing the number of trees per hectare, perhaps changing the species, or pruning and removing understory to help prevent candling and those really intense crown fires that can occur. So one side effect of these fuel management projects that focus on forest is that you're generally opening up the canopy. And when you open up the canopy, you start to get an increase in your herbaceous material. That's your graminoid species, also shrubs, things like that. And once these dry and cure, you're left with an incredibly volatile and easily ignited fuel type. I'm sure everyone knows that from whenever you've tried to start a campfire. It's a lot easier to start with, newspaper or dried grass versus just trying to hold a flame up to a full log. So with targeted grazing then, the goal is to address this fine fuel load that's not addressed through other fuel management strategies. To reduce the fine fuel load or to break up fuel continuity, while attempting to ensure that other values aren't negatively impacted. This includes tenure requirements around stubble height and forage use levels. So grazing is going to be used because although you could use mowing or other mechanical treatments to address this understory herbaceous material, grazing animals is cost effective and it makes use of existing resources and grazing agreements that are already in place. It just targets them to address a specific issue. So with that in mind, on to our pilot sites and experimental design. We established 4 sites for 2020, one in Peachland, one in Summerland, and then 2 in Cranbrook. Monitoring was carried out in the core area of interest, which was located 2 kilometers from community infrastructure, with intensive data collection concentrated within 400 meters of infrastructure. This distance is used province-wide by the BC Wildfire Service for wildfire prevention planning around communities. And for this, I'll focus mainly on the Summerland pilot and the Peachland pilot as well. This picture, you can see this is the Summerland pilot, and it was pretty nice overlooking Okanagan Lake in the summer. So monitoring has these 2 main components. Intensive monitoring, which is data collection, like intensive data collection, occurs once a season at permanent macro plots, while extensive occurs every 2 weeks during the grazing period. And that's over that whole 2 kilometer range. So this is our extensive monitoring design. As I said, it occurs across that 2 kilometer boundary, and it gives really broad coverage of the pilot site, occurring every 2 weeks during the grazing period with the intent of providing rapid information to the grazing managers to address any sort of adaptive management that needs to be implemented. What we were looking at through extensive monitoring is we traveled this route, you can see, through these predetermined plots to get broad coverage of the site. And at each plot, we looked at our leading plant species, height, percent cover. We estimated grazing use, characterized fuel continuity, and then undertook riparian health assessments, as well as important plot attributes such as slope and aspect. And this is to give us an idea to just characterize the site and to manage and note any changes that occur during the grazing period. Here's an example of results from our extensive grazing monitoring, and this is around grazing use. So we went through our plots, analyzed the estimated grazing use, which provided us with an idea of distribution. You can see in the area the green area there, you have higher levels of use, whereas in areas outside of that core wet swale in the middle, you're having less grazing use applied. So in the area that's close to community infrastructure, which is located here, this boundary here, we have little grazing use in this area. So to affect that, or to effectively target grazing into those areas, there needs to be distribution strategies to achieve targeted grazing. And then fuel loading was another item that we looked at in our extensive monitoring. We have this noted as continuous, sparse, or sporadic, and the red dots note continuous fuel loading. And as you can see, again, within that 400-meter boundary area close to the community infrastructure, it is primarily red, and we have continuous fuel loading. So in Summerland, the majority of the area had continuous fuel loading. And this is because there was really vigorous grassland communities, and this year was a highly productive year for forage. So although there was grazing on the site, it did not achieve effective fuel mitigation through the grazing treatments. And we did have these continuous and high levels of fine fuels noted across the site. Well, intensive design, this is for the intensive monitoring component of the research project. This was quantitative. It occurred on these macro plot areas that were smaller, randomly selected within our 400-meter boundary from community infrastructure, and provides data that can be used for statistical inferences. And then this data collection occurred following the grazing period. And there's a list of variables that we measured across these intensive macro plots located on the right-hand side of this slide. So it was everything from plant biomass, litter, we identified plants and their cover, woody substrates, fuel, and then range health considerations such as occurrence of soil movement, capping, crusting, etc. And then we also managed or reviewed conifer regeneration, which was less of a consideration on the Summerland site in particular because it was primarily grasslands. So these are where our macro plots were located. They're within this 400-meter boundary from community infrastructure, and they were randomly placed there using a stratification approach. And so I will also note, this is what the macro plots actually look like. So we have a 100-meter baseline transect where we measure things like stubble height and fuel continuity. Within the middle there, we have plant community transects where we take 5 transects to characterize the plant community, and nestled within there are conifer regen plots. Along either side of those plant community transects, we have our forage cages where we monitor and measure both the biomass and the plant community cover within each forage cage and its uncaged pair. And we do that to compare what the community is, what the plants are within the cages, and then what they are uncaged, which received grazing pressure, and then also to compare biomass between the two. So it was a pretty substantial amount of data that we collected in here. And this also, of course, included range health assessments too. So it was a very substantial amount of data collected. This slide here, you can see on one side, we're doing our plant community transects, and then there's an example of a cage. So one really important thing that came out of this was we characterized our plant communities. This allows us to monitor community changes and shifts in ecological status or integrity that may or may not occur through grazing. And this will be monitored annually as the project moves forward to see if grazing pressure causes any sort of shifts in the composition of the plants in the macro plot. Summerland was primarily a grassland area that was big sage, blue bunch wheatgrass, along with cheatgrass and needle and threadgrass. Whereas Peachland, it was more productive, rough fescue with pine fir leading forested and blue bunch wheatgrass, pine grass. And then this is, I think, is where the most exciting and important results came from this study. These are all very preliminary. This was the first year. So our biomass results, we found at Summerland and Peachland, both of them, grass biomass and total biomass was not significantly different between our caged non-grazed controls and our grazed samples. However, forb biomass was significantly different. And there was higher forb biomass in the controls that were not grazed. The Peachland pilot site was interesting because it actually did not receive any cattle use in 2020, but we still saw this significant difference in forb biomass between the caged and non-caged controls. And so this indicates that there is ungulate use occurring on this area in the absence of cattle use that needs to be taken into consideration when establishing any targeted grazing prescriptions. So another component that we looked at was grass height that gave us some results. So at Summerland, our grass height analysis showed 15.2% use of blue bunch wheatgrass in the grazed samples relative to our non-grazed controls. And the interesting thing too is that in Peachland, we saw something similar. And remember, Peachland didn't receive any cattle use in 2020. However, you're still seeing 9.7 and 9.8% use of pine grass and rough fescue, respectively, in your non-caged versus your caged controls. And remember, there's no cattle grazing. So the use of these grass forage resources in Peachland gives us a bit of an indication of the ungulate use and forage needs. And as I mentioned, that's really important moving forward if we're going to make sure that targeted grazing prescriptions aren't having negative impacts on other very important values in these areas, such as wildlife resources. So considering, again, animal use, we wanted to also find a way to measure that and potentially quantify it. And we were looking down anyway when we were doing our plant community transects. So we figured, why not record the poop that we see? So cattle manure was present at 2% of the plots in our Summerland site, whereas ungulate pellets range between 2 and 30% presence across those macro plots. Peachland, of course, no grazing by cattle, so there was no cattle manure, but ungulate pellet presence was between 2 to 8%. And remember, where we were seeing about 9 to 10% use of forage at Peachland. And so that kind of correlates a little bit with the ungulate pellet presence, although we'll have to do more specific analysis on that. So conclusions and considerations. Remember, this was our first year of this project. These are very preliminary results that are going to require ongoing monitoring. We did find that livestock grazing was too light to address fine fuel load at Summerland site and of course at Peachland because it didn't receive grazing. However, it did allow us to identify our primary range areas. Riparian helps. It helped characterize current plant communities and gives us an idea of the infrastructure needs that were going to be required to have successful targeted grazing prescriptions. Biomass and grass height analyses showed that there was some forage use at Peachland in the absence of cattle use. Again, that's going to help us to incorporate those wildlife values into future targeted grazing prescriptions. Characterizing our plant communities will allow us to monitor any shifts and changes in composition and ecological status moving forward. And additionally, we're planning to use a lot of this data to model fire behavior and test whether or not targeted grazing impacts any of our fire behavior. And my last slide is this. And this was provided to me by Reg Newman. And I think that it really helps visualize the issue that we're trying to address in here. So this is a range reference area, and the inside has not been grazed for many years. And it is very obviously a fire hazard with all of the fine fuel loading that's occurred in it. However, the outside has been grazed and it might be potentially unhealthy. So we're really trying to walk the fence line there and reach something that addresses fine fuel loading concerns while not having negative impacts on the ecosystem and ecology. And sorry, Haley, I went over time. I can't help myself.
Thank you so much, Amanda. What a fantastic presentation. You weren't really over time because I took up the first 5 minutes, so it's all
Okay.
good. But what a terrific presentation. I love that last visual you have of that fence line of the two extremes that we're trying to balance. With that, I'm going to open it up to questions. So for the audience members, you're welcome to chime in verbally if you would like when there's a pause, or you can put them in the chat and I'll read them out for Amanda. So while we get started, Wendy Gardner had a question, Amanda. She asked, how are you managing the grazing? Are you using a management intensive grazing approach? And what is the utilization target that you are aiming for?
So on this, specifically in the Okanagan, we were utilizing conventional grazing for the Summerland site. However, at our Cranbrook sites, there was management intensive grazing that occurred. And as for targets, that's the thing that we're actually trying to parse out for this, is that different communities will have different targets relative to stocking rates on what can and cannot be effective as for reducing fine fuels. So that's actually going to be a big outcome of this project, is we need to figure out what those targets are, because it's really difficult to determine what they are without having something on the ground to give you results first, which is why I think it's good that we utilized conventional grazing at Summerland, determined that it didn't effectively reduce our fuel loading issues. And then we also had Peachland, which had no grazing, as a really strong control to tell us that there are, there's these other uses of the forage resource that need to be incorporated. So I think it's going to be a slow build up to figure out what exactly we need to do to reach those targets and what they are. So that's a really good question. Thanks, Wendy.
I think I kind of jumped the gun because I asked it early, and then it became clear that you were just trying to get the assessment down. But are you planning next year to based on the data you guys collected this year, to try and up the utilization, or is that not going to be part of the pilot project?
I think that is likely something that we will try to do to better address the fine fuel loading issues, but it depends on partnerships and how we will effectively reach those stocking rates. So it would be good, in my opinion, to see additional grazing pressure and then use some good distribution tools and techniques to target that pressure to the specific areas we want it to be, close to infrastructure. But it is dependent on a number of factors. But yeah, it would be good to see that. So hopefully, and two, at Cranbrook, we did effectively target the grazing with heavier stocking rates close to community infrastructure. But I'm right in the middle of weighing all those biomass samples. That sampling effort was a little bit later than the Okanagan stuff. So stay tuned for those results.
Thanks, Amanda. We have another question from Bob Gillespie. He asks, are there plans to look at changing grazing management and monitoring the results? And I think you might have just touched on this a little bit.
Yes, depending on what comes out of this research, we would probably have some suggestions and recommendations for changes in timing and intensity of grazing. And it would require some more, it would definitely require some more stringent monitoring than non-targeted grazing treatments. So that would be part of the recommendations coming out of this project.
Awesome. A question from Clayton Bradley. He asks, how useful is grass height analysis when the majority of the biomass will be closer to the ground?
Yes, so I come from a different sort of region that we didn't so much use grass height analysis. So maybe I would turn it over to someone from Range Branch, such as Clayton, who could speak to that better.
Clayton, feel free to chime in if you have a mic.
Yeah, can you hear me?
Yes, we can.
Right on. Yeah, it just had me thinking about, utilization percent versus grass height versus amount of biomass. And yeah, I think just a question in my mind, if it's more biomass adding to fuel for fire, you might still have a hazard there where you might have removed 50% of the height, but you haven't removed very much of the total biomass. So yeah, something that we can talk about when we go out on our field tour in another week here.
I agree. No, and I think that that's an important thing to note, Clayton, and I'm going to put that in the reports because I was having similar questions myself, but just don't have the familiarity with using grass height for analysis that that yourself and others in your program may. So thank you.
Yeah, thanks.
Another question from Wendy. You discussed modeling fire behavior based on your fuel loading data. What program are you using to do that?
Well, that's a really good question that our wildfire people will have to take care of. So that's something that we'll be leaning on some wildfire specialists within the province to help us with, because I'm a range ecologist. I'm not really a fire specialist. So I think that we'll probably use, I think it's the fire behavior prediction modeling.
Yeah, the FBP.
Yeah, the FBP. So it's likely going to be that, but it won't be me doing it because I don't quite have that skill set. So we'll get experts on that part.
Oh, come on. You took fire ecology and management, Amanda.
I know, and it was taught by the best person ever, but I just can't remember that long ago. I'm getting older now, Wendy.
No, it's not true.
It sounds like it's quite a collaborative project with many different people involved, which is really cool. We have a question from David Borth. He says, or he is wondering about the causes of limited grazing near the community infrastructure.
So within the context of the Summerland site, actually, I think I'll go back to the map to address that.
Okay, awesome.
So this is our grazing use map here. And it's because the primary range area is this darker green part right in the middle. I don't know if you guys can see my mouse here.
Yes, I can.
Okay, so it's this darker green part. You've got water resources, and then this is a moisture receiving swale that is dominated by Kentucky bluegrass. And so cattle, of course, they're a little bit lazy. They like to hang out near water and really good food. So the reason why there wasn't as much grazing pressure up within this area here, that's within the boundary of community infrastructure, is just because they didn't have to, they weren't coming up to graze as intensively here. Although there was salting located within this boundary area to help aid in distribution, the grazing pressure was just quite light, and they didn't really have to venture too far up these hills here to into these areas that are close to the community infrastructure.
Thanks, Amanda. It's David. Just kind of a follow-up question. You probably don't see it here, but I'm speculating and wondering if adjacency of people and dogs and cats and everything else might scare cattle away from those adjacent areas. So obviously that's not the case here. It's more about the preferred grazing area. Kind of a follow-up related question is, what's the level of community acceptance, whether that's just the neighbors or the communities themselves, city of Cranbrook, that sort of thing?
Well, it of course is dependent on the area. For this study site, there seems to be a high level of community support. It is within, the ranching area of the Okanagan. Cranbrook, we have two really excellent tenure holders that have really good relationships with the communities that are close to their tenures. And so there's been, from what I'm aware of, a fair bit of support from the community in that. Despite some wayward cattle getting out in the areas. So it really is dependent. We're looking at potentially implementing another pilot in southeastern Kelowna, and that would be right in the municipality. And that one is interesting because a lot of the nearby communities were originally quite hesitant to have cattle in the area, but with all of the fire behavior and the fire risk associated with all these overgrown grasses and everything, they've come around and are actually quite supportive of implementing a pilot to address those fuel loading issues with cattle. So It's hard because sometimes there is a lot of hesitancy and a general dislike of cattle on the landscape in certain areas. And so it's good when we can, through education and discussion, discuss and say that they can be used as an effective tool to help with maintaining and safeguarding your communities from wildfire risk.
Okay, thanks, and great presentation.
Oh, thanks.
Thanks, Amanda. So just in the interest of time, it is 12:30, and I do know these sessions are half an hour, but we're having a lot of great questions coming in. So I welcome anybody who has the time to stay on. I know Amanda has a few extra minutes, so we'll keep working through our questions for the next 5 or 10 minutes. But if you do need to leave, feel free to leave at this time. I will quickly put in my plug here for next week. Our session is on Tuesday, October 13th at 7 p.m. The presentation is titled Rangeland Plant Responses to Arbuscular Mycorrhizal Fungi, Options for Ecological Restoration, and it's presented by David Prado-Tarango from Oregon State University. So I invite you guys to tune in next week at 7 p.m. for that, and we'll get back to our questions with Amanda today. So jumping back in, Amanda, sorry for the interruption. John asks, have you brought in Ministry of Environment data for the Summerland prime wildlife wintering on the area? Also, without better fence boundaries, it's hard for ranchers to increase stocking level, is an additional comment he had.
Yes, so we're not actually looking at increasing stocking levels. We're just looking at targeting that use to specific areas. And relative to the critical winter use, that's a really good question because the Summerland and Peachland sites are within that critical winter range for ungulates in the Okanagan. And we do have a wildlife biologist that works in the area as part of our committee, our stakeholder committee that's working on this project. So that's being taken into consideration. And that's why I think it's really good that we had the no grazing on the Peachland site. It hasn't been grazed for at least 10 years or potentially more. I'd have to look in my notes. So it's really good that we had that site with no grazing so that we could attempt to quantify some of the wildlife needs. And winter range is really critical for ungulates in this area. And we're tied in with I think it's the Southern Interior Mule Deer Project too, through our wildlife biologist.
Awesome, thanks, Amanda. Maureen Malenstein asks, are you able to access all the lands which could be affected by this project?
Are we able to access them?
Yeah, so I think...
Oh, this project is limited currently to Crown land that's along an urban interface. And we also need to have tenure holders that are supportive because it does require additional work, through infrastructure and management. So we are able to, because this is partially through the province, we're able to access the lands that people have interest that may be of value to receiving some fuel reduction.
Awesome, thank you. The last question we have in the chat here is, what is your criteria for fine fuels? So how would you define them?
Yes, so currently our criteria, our criteria for fine fuels is we're measuring mostly graminoids along with shrubs and other herbaceous material, uniforbs. And then as part of monitoring, we are also reviewing some of the finer woody fuels. So I'd have to look at it specifically, but we got it from, oh, I'm sorry, I should know this, but okay. It's basically twigs, anything, I think that it gets up to 3 centimeters in diameter.
2.5.
2.5, okay. Thank you, Wendy. Got you. So good at fire ecology. I should have listened more in your classes, but that's what we're measuring it up to for fine fuels.
Thanks, Amanda. Another question came in from Thomas. Have you considered a different class of livestock, such as sheep, for their ease of herding? So
that's a really good thought. Sheep could be used potentially in this, but there are differences in what different classes of livestock will select for. So cattle are good because they're already on the landscape, as I mentioned. There's existing agreements so we can make use of them, and they also are bulk feeders. So they'll select for grabnoid species primarily, which in the case of this project, that's what we're aiming as our primary fine fuel that we want to reduce, is the overabundance of grabnoids. So sheep, on the other hand, are considered an intermediate feeder. So they do have a bit of adaptability where they can select, they will eat grass, whereas goats, on the other hand, aren't really going to select for grasses. Sheep will. However, they tend to prefer selecting for forbs and browse species. So they may not be well suited for grazing, for targeted grazing for fuel reduction, when our aim is to reduce the grass on the landscape, if that makes sense.
I think so. Thanks, Amanda. Is there any last questions, comments? Anybody want to speak up with anything while we have Amanda on the line here?
No, great job, Amanda. It's such an interesting project, and I love how you guys are making the focus about considering all of the other factors and walking that line, like you said, between can we reduce fire and fuels, but still keep the ecological integrity and health of those rangeland systems. And I think it's always a hard question with any type of fuel management, even when we're looking at forest structure. It can't be all about just reducing fire. We have to think about the ecological integrity and function of those systems as well. And it's hard to do both. But it's a very timely project and good questions. I love your pretty extensive amount of data you guys are collecting. So I'm excited to see what comes out of it. Thanks so much for sharing with us.
Oh, thank you, Wendy. I appreciate it. And yeah, it's a struggle straddling that line there. So hopefully we'll get it. And like I said, I'm glad that we started at a point where we can say, oh, we didn't effectively reduce fine fuel loads, and maybe look at increasing stocking or increasing density in how we target grazing, versus the other way where we go, oh my gosh, this was very problematic. So I think it was done in a very careful and well-considered way. So I'm quite happy with how it's going.
Thank you so much, Amanda. With that, we'll wrap up this week's session. So thank you again, Amanda, for your amazing presentation. Very informative. And thanks for everyone for tuning in.